This video is brought to you by LogRocket, the front-end performance monitor that records videos of user sessions along with logs and network data, surfacing problems and revealing the root cause of every bug. Try it today at logrocket.com/YT.
Hey, how's it going? It's Lee Halliday, and in this video we are going to be building a GraphQL server-side API, so the back-end side of it in Next.js. That sounds a little bit weird because people think Next.js, it's a React framework, what's the deal? But they have awesome support to build a back-end server-side into your Next.js React app. So to get started, I've got a React app that's basically nothing right now. I've got literally 0 pages going on. I have installed the dependencies that we're going to need though. And specifically what we're going to build a GraphQL API that's going to load data from a Postgres database, but we're going to make sure we do it efficiently and avoid N+1 queries. If you're thinking, I'm going to be using MongoDB, will this help me? I think it will help you anyways, just to see how we pull things together. And if you want to swap out Postgres for another database, be it Mongo, MySQL, go for it. I think a lot of the principles will still apply. So first things first, a couple versions ago, but fairly recently, Next.js added support for this page inside of an API folder. So if you create a file in here, so we'll call it graphql.js, you can actually put server parts of your app backend, and these acting like sort of your typical expressway node. It's all server side though. So just to get things kicked off and going, we are going to build the most minimal page possible. So we're going to export a default function. And functions on the server side in Next.js, they receive a request and a response, just sort of like Express if you've worked with that before. And we are going to simply respond, end this response with GraphQL. That's it. Thanks for watching the video. No, we're just getting started. So let's start our Next.js app, pop open the browser, and if we load the page now, we get that wonderful text GraphQL. All right, let's do this for real now. So the first things first, we are going to import something called GQL, GraphQL tag basically, from Apollo Server Micro. That's the Apollo server you want to use when integrating with Next.js. We also want to import Apollo Server, which will be used later, but this should get us started. So when you're defining a GraphQL backend, the first thing you need are type definitions. This sort of describes your GraphQL schema. So type defs equals GQL, you use these backticks, and in here you define your GraphQL schema. So to begin, why don't we have a query just with one field called hello, which will return a string. Once we get this working, we'll change this to actually pull data and whatnot. We're going to be showing albums and artists for each of those albums. Next thing, after defining our types, we are going to define our resolvers. So const resolvers, and this is an object. So we're going to be resolving the query right now, which has a single field called hello. So resolvers are basically functions that look up the data for each field that the user is querying from your GraphQL API. So this is going to be a function. These functions receive 3 things. They receive a parent. Typically you wouldn't use a parent on a query, but when you get nested, you may want to reach up and grab the parent. Next thing will be the arguments. We're also not using them, and the context, also not using them. Because all we want to do here is return, let's just say hello. So when you query hello, it says hello. Great. Next thing, we want to create an instance of the Apollo server. So const Apollo server equals new Apollo server. And into this, you pass our type defs and our resolvers. We're not done yet. we need to create something that is called a handler. It sort of interacts with that original function that I exported. It takes the request and the response and it parses what's being queried and it builds up the JSON response. So the handler handles all of that for us. So handler equals Apollo server dot create handler. And here you can pass some options. We're going to tell it what path it lives on. So it's API/GraphQL, like that. And then you are going to want to export this handler as the default export. So this is similar to that function I mentioned earlier that receives the request and the response and deals with that. Now there's one extra thing that I'm actually just going to stick here. We need to export a variable called config to just tweak something about the way that Next.js is handling the requests. We're going to tell it for the API, what's it called? Body parser. We don't want it to parse the body. We're going to leave everything up to the handler and the Apollo server to deal with that. I think we're good to go. So why don't I think we still had it running. Yep. So if I refresh the page now, I actually get a pretty cool built-in GraphQL Explorer that just Apollo server comes with this. If you make a GET request in the browser, you'll see it pop up. You can open up the schema. You can see that we're able to query hello. It's going to return us a string. So we can come in here and make our first query, hello. And what do we get back? Hello with an exclamation mark. So that tells us our GraphQL server is working. Let's make this use real data now because nobody wants a server that just says hello. So our data comes from Postgres. To take a look at what the database, I've already created it because I didn't want to go through all the trouble of creating migrations and stuff in this video. But in the article that this video will link to and that it's probably being embedded into, there's steps on how to set up your database, how to create these migrations, run them, all that stuff. But for the sake of this video, the database is already here. I've got two tables, artists with one artist in here, Comeback Kid, my favorite hardcore band from Canada, and then their albums. So they've got 6 albums. It's related to the artist on this artist ID column, and we just got the name and the year of each of those albums. So that's the data we're working with. Nothing huge, but it will do the trick. I've already run the migrations to create these tables. So I ran one that would create the artist table with an ID, name, and URL columns. I also created one to create the albums table. So these have already been taken care of. And I already put the Next file JS in here that tells Next, which is the package we're using to connect to Postgres. It tells it how to actually connect there. So it's connecting through an environment variable I set up called PG connection string that tells it how to connect to this database I set up. So that's sort of where we are. And we're going to come back in here and start to build all of this support into our GraphQL server. So why don't we create a database variable that we can query our Postgres database with. So we are going to import Next from Next, and I believe it's a new. So we probably want a capital K then, right? Because it's a class. So inside of here, what do we pass? We pass a client of PG. So we're Next. I don't know if it can connect to multiple databases, but we're connecting to Postgres, so that's that. And we also have to tell it the connection, which is the same one we had over here in our Next file. So I'm just going to copy that. So it's process.env to grab all the environment variables, and we're grabbing one that's already been set. I didn't go through the trouble of showing how to set this up because wherever you're deploying this or whatever system you're working on is probably different than mine. So just know that you do need to have an environment variable set up with a Postgres connection string. I'll show you quickly what it looks like. Where do I have it? let's open ZSHRC is where it is on mine. Computer's going a little bit crazy. It's part of the fun. All right. There we go, PG connection. Hopefully there's no password in here. We're all good. Okay, so this is the PG connection string I was talking about, just to connect to my local Postgres database. So with this setup here, why don't we tweak our query? So what we're going to be querying is albums, or our albums. And what do they return? They are going to return an array there'll always be an array, and it will be an array of album. And if there's an album, it will be there, so we'll put an exclamation mark. The arguments that this will receive are first, which is an int equaling to 25, so the first 25, and offset, which will be, do I want first? Yeah, I think I want that. First and, no, I think I wanted to call it skip, that's it. Skip is also an int of 25. Basically, these are going to be if you're used to databases and querying, you're going to say, grab me the first 25 records. Oops, this will be 0. Skip 0 because you're starting at the first one. But if you want to grab sort of records 25 to 50, you'd set your skip to 25. So you can start at record 25. So if we define our types now, so we've got an album type. Let's say this has an ID of type ID. It's also got a name of a string, and it also has a year of a string. And these are always going to be there. Next, we will build a type of artist. So how are these related? Well, each album has an artist. And what does an artist have? Well, it will have an ID and a name. So we could build sort of like circular relationships where an artist also has albums, but for the sake of brevity, it'll take me too long. I'm just going to leave it like this. So with our type defs updated to be able to support albums, we could even come into we could see what happens if we ask for albums, ID, and name. All right. It's failing. And it's failing because it's just not set up to, there's no resolver for, something's freaking out. Hello, defined in resolvers, but not in schema. So it's saying you've built a resolver for hello, but that's not even in your schema, so what are you talking about? So why don't we fix this? So we are going to build a resolver first for albums. And it's a function that takes in a parent we won't use, args we will use, and context which we won't. I'll get into context in a little bit and how we're going to use it to efficiently use DataLoader and the data loading pattern to avoid n+1 queries. So this is a function, and what will it return? It will return db. From it, we will select star. From the albums table, we will order by, why don't we order by year? Ascending, so get the oldest ones first. And we'll say limit, args.limit, or first, sorry. Yep. And our offset will be our args.skip. Like that. They could ask for the first 5 million records. You may not want them to do that. So we can say math.min, let's say up to 50. So pick the min of whatever they ask for 50. That will help save our database and our server. So we now need to build resolvers for the other things that can be returned. For example, album and artist. So if we build an album here, so what does an album have? It has an ID, And we actually don't even really need to do this, because if you're just going to return the exact property from the object being returned, you don't need to define a resolver for it. But for some reason, I like putting the ID, so we'll leave that here. So we do care about the parent this time. It is an album. We don't care about args or context. And it will simply return album.id like that. So we're going to do the artist as well. So artist, args, context, and it will return artist.id. So we don't need to define the name or the year, because those are just straight up reading the properties from the object. So you don't even really need to do the ID, to be honest, but it at least lets us define the resolver here. What we do need to build a resolver for, though, is that when you ask for an album's artist, we need to go and load that. We'll do it the inefficient way first, and then we'll update our code to grab it efficiently using a data loader. So here we are grabbing the artist, and we are given the album. Args we don't need, context we don't need. And what we want to do here is, using the info from the album, go and find the artist. So db.select star from the artists table where, so now we need a where because we're finding a specific artist. And so it would be where the ID is equal to album.artistID. And we want the first one. So with that in place, why don't we see if there's any errors on the screen? Select.order is not a function. That's because it's order by. Where did I put that? Order by. Try again. There we go. So we are pulling all of the albums. So if we look at this, we're asking for albums. So we would go to the albums resolver, which is querying all the albums. And then how do we resolve each album? We've got this album resolver here. I defined an ID one, but as I said, we can probably, delete that and nothing happens. So feel free, but this is just to give an example of how to build a resolver. What we did need to resolve, though, is how to load an artist. So if I ask for this album's artist, and we get the, let's say, the ID and the name. Cannot return null for non-nullable field. So that means it wasn't able to find the artist. So let's try to troubleshoot what's going on. We've got an album. We want to select from artists where the ID is equal to this. Maybe it's not album.artistID and get the first one. Oh boy. Great. It helps when you return values from functions. All right. Thank goodness. Okay. So now we're pulling the artist for each album as we're looping through these 6 albums. But there is an issue that's sort of hidden. If I turn debug on for the next database connection, and I rerun this, we come down here and look how many queries it's running. It's doing what's called an n+1 problem. What it's doing is it's doing one query, that's the 1 in the n+1, to find all the albums. And then it's doing an additional one for each album. So that's the n. However many albums there are, it's going to do an additional query to find each artist. This is no good, because imagine if we were loading 50 artists. That would be a lot of extra load on our database. It would slow things down. But there is a solution. So the DataLoader pattern from Facebook, they came up with a way to sort of, well, instead of loading each album individually, why don't you just give me all the IDs of the albums you want to load? I'll do one query to load them all at once and load them in a single batch. So I have installed a package for this called the DataLoader package. And we will use that to query things efficiently. So import DataLoader from DataLoader. And the first thing we're going to do, it's not a poller. That's funny. Let's make sure it still works. It doesn't. Oh, maybe you import them like it had it. So we probably don't even need that. There we go. Well, sorry about that. This is how you import those two things. I love how it just, when I typed in Apollo server, it knew how to add the correct import automatically, even though I had done it wrong. So that's pretty cool. Anyways, so we're going to use our data loader to find things efficiently. The first thing we're going to do is we are going to set up an object called a loader. And you basically build, you have one property for each thing you're trying to load. So we are trying to load, in this case, an artist. And the way it works, it's a function that's going to receive the IDs of all the artists that should be loaded. So we will go and select them from the database. So select star from artists. There's one called where in. So we're looking for the ID where it's in the list of IDs that were passed. Once we have found all of the artist records, what we have to do is take all of the IDs, map them, and find the corresponding record that was found from this query here. So we're going to say then to wait for this promise to resolve, and that will give us the rows. We won't do anything with them yet, but what we're going to do is we're going to map the IDs. So for each ID, we need to find the corresponding row record. So we'll now say rows.find, and we want to find, this is getting a little hard to read. So IDs.map, that gets us an ID, rows.find, and that will be a row where the row.id is equal to the ID. Okay, that's a little bit easier. This is a mouthful, so I'm going to go over it again. Promise resolves, we're given a bunch of rows, an array of rows. We now take these IDs and we map them. So for each ID, we want to basically find in the rows the row where its ID lines up with the ID of the one we're mapping. So what will eventually be returned, don't forget that, is an array of the artists in the same order of the IDs passed into it. That's sort of how it expects things to work. But we haven't done anything with this yet, and the first thing we actually have to do is we have to provide this loader in the context. So context, you've seen it being passed to all our resolver functions, but we haven't done anything with it yet. Context is a way to basically provide some global context to each of your resolver functions. So this is where you, A, would put a data loader, B, it's where you'd put like the user who's authenticated, and any sort of global settings you want to pass to every resolver function. So context, it will be a function that will return an object that has the loader inside of it. What that will allow us to do is to basically come up here where we're resolving the artist and grab from the context the loader. And instead of querying each artist individually, we'll use the loader, specifically the artist loader, to load the album.artistID and make sure to return this. So this will use our data loader to basically store up all the IDs, pool them, do a single query, and do things efficiently. So if we run this again, loader.artist.load is not a function. All right, I did something wrong. So I've got my context. I've got my loader here. Oh, I know what's wrong. So if you're following along, this is the joys of programming. But artist here, you don't just pass a function. You do pass a function, but you pass it to an instance of DataLoader. Like that. So the DataLoader has a function which does all of that, what we did before. So if we rerun this, now it's working. I don't know why it's showing me this albums query twice. I don't think it's actually running twice, but the important thing is that, see here where we're loading the artists, it's only loading it this for ID 1 here, but it's only running the query once because it only needed to load artist with ID 1 a single time in a batch rather than individually querying it every time. Awesome. So we ran into quite a few roadblocks in this video, but to be honest, when you're writing 85 lines of code that does Apollo servers, GraphQL, resolvers, all that stuff, that is to be expected. So just to quickly recover, go over what we covered in this video. The first thing we did is we discovered, hey, you can build backend using API routes, backend server functionality in Next.js. Awesome. The first thing we did was we defined our GraphQL schema and how to resolve the data for that schema. So how do you get the data for each field? Skipping the data loader, we built our Apollo server, passing in the type defs and the resolvers. We from that server created a handler. This allows us to interact with the way Next.js wants and respond to requests from the browser and then build those responses back. And we also had to set the body parser to false so that it works correctly. And you want to export this handler as your default. It's a function, the thing you're exporting. Next thing we did is we hooked this together with our Postgres database using Next. So we set up our connection to the database using this environment variable, and we then updated all our resolvers to pull data from the database. But we discovered through doing this that this one specifically, where we load the artist for each album, was inefficient. It was doing an n+1 query. So we introduced a data loader so that it would store up all those IDs into a single query to load them all at the same time. So this loaded the artist from our data loader, passing in the ID. But how that manifested itself is we defined a loader object here that had a loader for an artist. It was an instance of DataLoader which received IDs, queried them all, and then mapped those rows back to the IDs that were passed in. In our case, it was only one, but it was an array of one. But we had to pass this loader to our GraphQL resolvers using context. So we created the context here, had it a function that returned this object with our loader on it, and again, that's how we then had access to the loader here to find it. So Next.js is awesome. You can build your GraphQL server API right in there. I hope you enjoyed this video. Take care, everyone. Bye.